Hello, assalamu alaikum, my dear friends. Welcome to my YouTube channel. Today we will discuss our next topic, that is suspensions. In the previous lecture, we discussed about the types of solutions, where we learned that a solution have various types, like we discussed about solid solutions and liquid solutions, and the third one was gas solutions. For the details, you can watch my previous lecture, that is the types of solution. Today we will discuss suspensions. We have studied that the substances which are soluble in water or any other liquid, like we have salt, sugar, these are soluble in water or any other liquid. These substances form solutions. These form solutions. Now, those substances which are insoluble in water or any other liquid, like we have chalk, that is calcium carbonate, or we have sand, or we have flour. These substances are insoluble in water, so these substances form suspensions. So let us dissolve an insoluble substance in a water to see what actually a suspension looks like. For that, I have a glass containing water. Now I have an insoluble substance, that is sand. I will add a scoop of sand in the water and I will try to shake it. What are we supposed to happen? What will happen? The sand will float and after some time it will settle down. It will settle down in the bulk. This interaction between the sand and water clearly describes what a suspension is. So what is a suspension? A suspension is simply a heterogeneous mixture. A suspension is simply a heterogeneous mixture. Heterogeneous mixture where solid particles do not dissolve in a liquid. And they just settle down after some time, and we can clearly see two distinct layers, one of sand and one of water. But why can't we see two distinct layers in solution when we make a true solution? Suppose I have a glass containing water. Now if I will add a spoon of salt in it and I will try to shake it, the salt is completely dissolved in the water. There is no distinct layers. There are no distinct layers. Why we can't see two distinct layers in a true solution? The answer lies in the size. Here the size of solute particles here the size of solute particles of a salt are very small. They mix with water very well, and so they can disappear between the water molecules. So the size of solute in a true solution are very small. It mixes with water or any other liquid quite well, so it disappears between the solvent molecules. The size of solute particles of a true solution is less than 1 nanometer, less than 1 nanometer. That is why we see a single uniform layer in a salt solution. We can see a single uniform layer where the solid or the solute particles are invisible. So in a sand water mixture, the sand particles are clearly visible. Which is why, because the particle size of sand, the sand particle size is very large, because in suspensions the solid particles are very large. They are more than 100 times, more than 1,000 times larger than a true solution. So if we have this solute size in a true solution less than 1 nanometer, but in suspensions we have solute 1,000 times larger than true solution. That is why in suspensions the solid particles do not dissolve in a liquid. Instead they are suspended throughout the bulk. Now I have some examples of this suspension. The number one is chalk plus water. I already told you that chalk is कैल्शियम कार्बोनेट प्लस वाटर. जब हम कैल्शियम कार्बोनेट और वाटर का मिक्सचर बनाते हैं, देन वी गेट a suspension. Likewise, we have another example. Milk of magnesia. The number 2 example is milk of magnesia. That is magnesium hydroxide. Magnesium hydroxide, that is milk of magnesia, which is a suspension. It is a medicine which is usually used in the patients who are suffering from this constipation. The third example of suspension is muddy water. Another example is this sand plus water. The third is flour in water. Flour in water. Now, what are the properties of these suspensions? Number 1, properties of suspensions. The number 1 is a suspension is heterogeneous mixture. Suspension is a heterogeneous mixture. The number 2 the particle size or the solid particle size of the suspensions are quite very large. Particle size of a suspension is very large. It is 100 times, sorry, 1000 times larger than true solution. Third point is the solute particles of suspension do not pass through the filter paper. Solute particles do not pass through the filter paper. So we can easily separate a suspension by filtration. So we can separate suspensions by filtration. The fourth point is, in suspensions we have two distinct layers. We have distinct layers in suspension. We have distinct layers in suspension. And the solid particles just settle down at the bottom. Solid particles settle down at the bottom after some time. The fifth point is, the suspension scatters the beam of light passing through it. Suspension scatters a beam of light passing through it, because the size of particles of a suspension is quite large. They are very large. That is why suspension scatters a beam of light. That is, suspensions show Tyndall effect. What is Tyndall effect? Tyndall effect is the phenomenon in which the particles of a mixture scatters the beam of light that is passing through it. Thank you. This was a little bit about the suspensions. In the next lecture, inshallah rahman, we will discuss about colloids. Thank you.